Next, we'll see propagation of uniform plane wave in perfect dielectric or lossless dielectric. So, first we discussed about propagation of uniform plane wave in free space. Now we are discussing propagation. That is, propagation is nothing but traveling of uniform plane wave in perfect dielectric or lossless dielectric medium. So, consider a uniform plane wave is propagating through a perfect dielectric medium. The properties of the dielectric medium were sigma is equal to 0, mu is equal to mu naught mu r, and epsilon is equal to epsilon naught into epsilon r. So the wave equation for electric field in general medium is del square E bar is equal to mu sigma dou E bar by dou t plus mu epsilon dou square V by dou t square. So substitute the above properties in equation 1. That is properties of dielectric medium we need to substitute. Then you will get here del square E bar is equal to sigma value is 0 plus same once again as it is. So finally del square E bar is equal to mu epsilon dou square by dou t square. Now we need to obtain the solution of this one in terms of only E bar only. That gives the solution of our analysis of propagation of uniform plane wave through perfect dielectric medium. So consider the wave is traveling in z direction. Then E bar is in x direction only, and hence this equation is dou square Ex by dou z square is equal to mu epsilon dou square E divided by dou t square. Dou square E by dou t square. Okay, this is the equation, and in this case wave is traveling in z direction, and finally we will get E bar equation is del square Ex by dou z square is equal to mu epsilon dou square Ex by dou t square. Next, Ex is equal to Em e power j omega t. Then take the differentiation, again differentiation. So then finally we get minus omega square Ex. Substitute this one in the equation 3. Then you will get dou square Ex by dou z square is equal to this. So finally we will get the differentiation, second order differentiation term. So d square plus omega square mu epsilon Ex. So d in this case is plus or minus j omega square root of mu epsilon plus or minus j beta. Beta is equal to omega square root of mu epsilon. So then the solution of that above equation is Ex is equal to k1 e power minus j beta z plus k2 e power plus j beta z. K1 is once again as per the previous case Em plus e power j omega t. K2 is Em minus e power j omega t. So substitute k1 k2 in the equation. Finally we will get Ex is equal to Em plus e power j omega t e power minus j beta z plus Em minus e power j omega t e power. So Em plus is nothing but electric field, maximum electric field on the positive side, maximum electric field on the negative side. Ex is equal to, finally you will get Em plus e power, both are having j, exponential term only, take j is common, omega t minus beta z. Here also same omega t plus beta z. If you take the real part, that gives the complete electric field solution. Okay, but the wave travels in positive z direction only. So therefore here in this case the negative Em minus is neglected. So Ex is equal to Em plus e power j omega t minus beta z. So this wave is travels in positive z direction only. So therefore Ex is equal to Em plus cos of omega t minus beta z. Cos of omega t minus beta. This gives the complete solution of electric field equation where the wave is traveling through perfect dielectric medium. Similarly, we can analyze for lossy dielectric medium also. The same concept will be followed for analyzing the propagation of uniform plane wave traveling through lossy dielectric. That means when the dielectric is not perfect, then that is called as a lossy dielectric medium.